everybody, this is going to be a quick video on how to graph categorical data. In this video we'll be going through pie charts, bar graphs, and how to not get misled by them. Okay, let's jump right into it. What are pie charts? How to not get misled by pie charts. These are all the points that you have to be careful of when looking at a pie chart or taking information from a pie chart. Firstly, whether the pie chart adds up to 100%, whether the other part of the pie chart is too big, where the pie chart has many parts, or if the pie chart is a 3D pie chart or not. I'll give you an example of each of these. Let's look at this pie chart here. The yellow part that's right here is the other section. The reason why I consider other in this situation as too big is because firstly it's the biggest part of this pie chart, and let's go through why there is even another section in pie chart. Why is there even an other section in pie chart? There's an other section in pie chart because there's too much information for the pie chart to display. So instead of displaying all information, it only displays the important ones, and all the rest of the information is put together as an other section. But when the other section is this big, the biggest part of the whole pie chart, that means there's possibly valuable information in this other section that should also be displayed. That's why the other section should not be too big. You should be trying to display as much data as possible, be as transparent as possible, and but it's at the same time it's also not recommended to have no other section at all. Imagine having a pie chart divided into thousands of parts, each 1.2% each, representing its own character or number or color, and trying to get information for that. So that's also not good. That's why it's important to have a pie chart, but the other section should not be hiding valuable information. Let's get on to, oh yeah, by the way, if you notice, after adding all these numbers, it's not actually exactly 100%, it's 101%. That's because some of these numbers here are rounded. Don't expect the total value of these percentages to be 100%. It's good if it is 100, but most likely, most of the time it's rounded up because of some of these numbers being decimal number. Just keep that in mind. Let's look at this 3D pie chart here. Can you answer this question for me? Which part of this pie chart is bigger? Other than the green one, is the blue one, yellow one, or the red one? Which is the biggest between these three? It's actually very hard to tell because I do not know the answer. It's just very difficult to tell. Whereas if you look at this pie chart here, even if I didn't give you the percentages, you would have been able to tell that the yellow part in this case is the biggest part. But in this case here, you do not know which one is the biggest part. So that's why it's usually not recommended to have a 3D pie chart. Although they do give the percentages, it's just not recommended because it's much harder to look at than a normal pie chart. Now let's go to the second part of the video. Let's get into bar graphs. These are all the important points when looking at a bar graph and taking information from a bar graph. Firstly, be careful of what the units represent. What I mean by that is the units in the x-axis, whether they are kilometers, meters, centimeters. That's a very important thing to note because yeah, it's just a very important thing to know. And secondly, see if the starting point of the axis is 0. This is also very important. I'll give you an example in a second. See if everything adds up to 100%. That's what we just discussed a second ago. And how much do the numbers on the x-axis or the y-axis jump by? Let's look at this example here. At first glance, Tuesday and Wednesday, the number of people who smoke in town X smoke a lot on Tuesday and Wednesday and do not smoke a lot on Monday. That's the information that comes to your eyes at first glance. But you slowly realize that this graph doesn't actually start at 0. So that means that this difference is magnified, it's exaggerated, because it's not starting at 0, and 50, which is actually a very big number, is only represented in 5 units because it starts at 45, and this seems like a much bigger number, and now the difference between these two seem a lot more than they actually are. But if you take the exact same data but display it differently, it doesn't feel that big. It doesn't feel like that big of a deal. Another thing you notice is that the number here, as you see, jumps from 10 to 20, whereas in this graph it jumps by 5, 50 to 55. So this 5 jump exaggerates the difference more. um, I'm not saying that you should always start at 0. There are cases where the number is a very big number and it's not necessary to start at 0, but don't start at a higher number just to exaggerate the difference. Uh, just take note and be aware of what the number starts at. That's what I'm trying to say. And also to be careful of how much the number jumps by. Now let's look at this. Yeah, the number on the y-axis jumps by 10. Now, finally, before we wind up, let's look at this graph here. The number of people who smoke in town A and town B. The number of people who smoke in town A is 4,000 and town B is 5,500. It feels for a second like it's not that big of a difference. Yes, town B, there are a lot of more people who smoke, but it doesn't feel like that big of a difference at first. Okay, fine. Before I continue, usually these numbers will not be put on top like this. I've put it on top for you so that you'll be able to see better, but usually it's not put on top like this. Okay. So this this graph, the jump in the y-axis from 1,000 to 2,000, through 2,000, 3,000, it jumps by 1,000, and that's actually a very big jump, much more than necessary. This difference is 1,500. It's actually a very big difference, but since the jump between two units here is 1,000, it doesn't feel like that big of a difference. It's not giving the difference justice because this the difference is so big. So this is a situation where the difference is too large. In the previous situation, we've noticed that the difference is too small and it's exaggerating the difference. In this situation, it's make the difference looks much smaller than it actually is. Okay guys, thank you guys very much for watching this video. In this video we have learned how to not get misled by bar graphs and how to not get misled by pie charts. We've learned how to not get misled by these two, and yep, that's all I'm gonna talk about in this video, because this all everything that concludes categorical data. In the next video we will be talking about how to not get misled by numerical data, graphing numerical data too. That's it for this video. If you have any questions, don't hesitate to write it down in the comments. If you want to see more videos and statistics like this, consider subscribing to the channel or check out my previous videos. So yeah, see you guys later.